All right, welcome back. So today we're going to be talking about how to solve quadratic equations using what's called the quadratic formula. We have heard about completing the square and we have practiced it as well, but today we're going to be talking about another way to solve quadratic equations, and it works for any equation, and we call it the quadratic formula. Again, so today's essential question is, how can you derive a formula that can be used to write the solutions of any quadratic equation that's written in standard form, right? So we have this very involved process that we're going to go through, and we're going to derive it, and then we're going to be practicing with it. So here we go. It says work with a partner, and we are going to be partners in this video. It says the following steps show a method of solving ax squared plus bx plus c equals 0, and explain what was done in each step. So the first step is that we're going to write out the equation. We have ax squared plus bx plus c is equal to 0. Well, what did we do just here? How did we get from here to here? Well, I noticed that we multiplied everything by 4a. Multiply everything by 4a. That's what I noticed was done here. Okay, so now we move on to here, saying, whoa, what happened here? How did we change from the second equation to now down here? Well, I noticed that on both sides of the equation, we added b squared. So we added b squared on both sides of the equation. Whoa. So now what happened here? How did we get from that equation to here? Well, I notice I have a negative 4ac over on the right-hand side, and I don't have a 4ac over on the right-hand side. So we subtracted 4ac from both sides. All right, let's see what happens next. Whoa, what happened here? How did we get from this equation to here? Well, if you notice, we have a perfect square trinomial right here. We have a perfect square trinomial, so we factored that. So we factored that into 2ax plus b squared. And now from here, you might be able to say, oh, well, what's the most logical step to do? Yeah, take the square root of both sides, right? We took the square root of both sides. All right, and if we want to solve for x, right, that's what we want to do for these quadratic equations. Well, we need to subtract b. So we subtract b, and we aren't done just yet because we want to get to x. We have 2ax. So now that means we have to divide. Come on, you can do it. Hey, whoa, spaz out, right? So for here, we had to divide by 2a. Dive. To dive by 2a? No. We need to divide div by 2a. And now we get this beautiful formula, which is called the quadratic formula. X is equal to negative b plus or minus, now all fraction, negative b plus or minus square root of b squared minus 4ac, and that's all over 2a. And you're probably thinking, wow, that's like really cool that we did that, but why does it matter, right? Like, why did this process matter? Well, what we did was we didn't break any mathematical laws. We kept everything balanced, and then we derived what we call the quadratic formula, which is going to help solving for any quadratic. So again, here is the core concept. Please pause the video and copy down the notes and be ready to listen to some more explanation. And then we're going to go into a practice mode. So here we go. The quadratic formula says the real solutions of a quadratic equation that's written in standard form, ax squared plus bx plus c equals 0. Again, this is standard. Okay, is this handy dandy formula. Let me box in for you. So it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, there's this handy dandy little tune that goes with it. um, x is equal negative b plus or minus square root b squared minus 4ac all over 2a. If you can remember that little jingle, okay, it's going to help you remember the quadratic formula. And notice that there's two main things here. It says that a cannot be 0. That means our denominator can't be 0. And this term right here, b squared minus 4ac, we call this the discriminant. Call it the discriminant. I'm just going to abbreviate and say discrim. Okay, that's this stuff right here underneath the radical. That's got to be greater than or equal to 0. Because for algebra 1 purposes, in order to have a real solution, we can't have a negative sign underneath the radical. So that discriminant has to be greater than or equal to 0 because we can't have a negative sign underneath the radical. So this is great, but let's show how we would use it. So if we want to solve this equation here, 2x squared minus 5x plus 3 is equal to 0, we're going to use a quadratic formula. So the first thing we always want to do, if we're solving by the quadratic formula, we want to write it out. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Perfect. Okay, so let's now start to fill in some of the values we know. Well, if we go back to the equation 2x squared minus 5x plus 3, our a value is 2, our b value is negative 5, and our c value is 3. I know a lot of teachers are going to have you write that out, so they might say, okay, right over on the side, a is equal to 2, b is equal to negative 5. And c is equal to 3. This is a good strategy to help you out, especially in the beginning, because we write it out and now it's not as confusing. We can just take these values of a, b, and c and plug it in. So let's do that. We have x is equal to the opposite of our b value, which is negative 5, plus or minus now the square root of b, which is negative, nope, come on. What happened there? Plus or minus the square root, there we go, negative 5 squared, minus 4 times our a value, which is 2, times our c value, which is 3. Let me extend the square root. And all of this is over 2 times our a value, which is 2. So I hope the colors are going to help us here. So now we just simplify. Well, x is equal to the opposite of b, and the opposite of negative 5 is 5. Plus or minus, let's simplify. Negative 5 squared is 25. It's crucial that we have the parentheses there, because a lot of students are going to write negative 5 squared, and they're going to do 5 squared, and then the opposite value of that to get negative 25, and that's a no-no. It's the quantity negative 5 squared. Minus now, 4 times 2 is 8. 8 times 3 is 24. I can actually get rid of that one there. And all of this is over 2 times 2, which is 4. We can simplify 5 plus or minus the square root of 1 over 4. And we know the square root of 1. We have x is equal to 5 plus or minus 1 over 4. Since we can simplify it, we're going to do that. We're going to write it twice. So our answers are going to be x is equal to 5 plus 1 over 4 and 5 minus 1 over 4. Well, 5 plus 1 is 6 over 4. And we can simplify that down to 3 over 2. We then are going to have 5 minus 1 over 4, which is 4 over 4. We can simplify that down to 1. So to clean it up a little bit, we get x is equal to 3 over 2, comma 1. Actually, I'm going to switch that order because I want it going from least to greatest. Just a personal preference. Perfect. And that's our final answer. And that's how we use the quadratic formula. We're going to have you practice a few. Okay, there's going to be 4 problems on the next slide. Pause the video, complete them, and then resume when you're ready to move on. So again, here are the four equations that I'm going to ask you to practice on and solve. And then when you're ready to move on, the answers are going to be on the next slide. Here are the answers for the 4 problems. Let me move this one for you. Oh, it wasn't grouped. Come on, there we go. There we go. So here are the answers for the 4 problems. We also have a very small topic to move on to. Here we go. We're going to bring back the discriminant. So interpreting the discriminant. Okay, please pause the video, copy down the notes, and then be ready to hear them in just a moment while I try to adjust this. Here we go. Okay. So when we look at the discriminant, okay, the discriminant is underneath the radical. So it's under the radical. There's 3 possibilities here, okay? That means if b squared minus 4ac, the discriminant, is greater than 0, for example, if I have the square root of 5, okay, it's going to have 2 x-intercepts. It's going to have 2 x-intercepts, or 2 real solutions. If we have the discriminant b squared minus 4ac equals 0, that means we're only going to have 1 real solution, or 1 x-intercept. And now if we have b squared minus 4c is less than 0, there's going to be no real solutions. There's going to be no x-intercepts because it will not cross over that x-axis. Okay, so that's how we would use the discriminant. If a problem says, hey, interpret the discriminant, how many solutions is it going to have? That's all that we need to do, is we have b squared minus 4ac and find that answer. If it's greater than 0, there's going to be 2 real solutions. If it's equal to 0, it's only going to be 1 real solution. And if it's less than 0, that means we're going to have a negative value. There's going to be no real solutions. In algebra 2, you're going to have imaginary numbers. But for algebra 1 purposes, there's going to be no real solutions. So let's practice that real quick. So it says determine the number of real solutions for x squared plus 8x minus 3 equals 0. Notice how it's not asking for the solutions. All it is asking for is the number of real solutions. So all we do here is we take our discriminant, b squared minus 4ac, and we're going to plug in our values. Again, we have a, b, and c. A is equal to 1, b is equal to 8, c is equal to negative 3, and we're just going to plug in these values. So it's b squared, so that's 8 squared minus 4 times a times c. We can simplify down. 8 squared is 64, minus now 4 times 1 is 4. 4 times negative 3 is negative 12. So notice how we get 64 minus negative 12 is 76. And this is greater than 0, which means that we're going to have 2 real solutions. This doesn't give us the actual solutions, but this will tell us it's going to have 2 real solutions, aka it's going to have 2 x-intercepts. Awesome, awesome, awesome job. Keep it going, keep it going. All right, so here are 3 problems for you to try out. It says determine the number of real solutions of the equation. So there's 3 different equations. You want to determine the number of real solutions, and when you're ready, the answers are going to be on the next slide. So pause it, complete it, and then when you're ready again, you can move forward. Smiley face. Okay, here are the answers to the 3. Number 7 has 1 real solution because our discriminant b squared minus 4ac was equal to 0. And then for 8, it's no real solutions because it's less than 0. And then for 9, it's going to be 2 real because it's greater than 0. Great job, everyone. I'm so proud of you.